unit testing. Now, at first glance, this might seem like this is far afield from what we were talking about in the course last week on voting mechanisms and algorithms and voting systems. So my question is, do you sense a pattern here of why we might have gone to this? It wasn't just a right turn. There's a connection between the two. And I'm wondering, for those of you who were able to look at the materials, if there were any key learnings that from looking at these that you'd be willing to share.
Feel free to switch on your mic or drop notes to the chats, as usual.
Yes, so we always have a lot of interactivity and we always enjoy that. So also type the question in the chat. What were the key learnings that you picked up from the material you need to?
We have ideas on systems engineering. What were the key learning? Aha, this is your question. Both emphasize the engineering aspect, being a professional, not just a hacker. Joanne, okay, thumbs up. Any other key learnings? I can share myself one that was actually brought up by Young's Eve, that we, for leveraging the NFTs, we have to integrate Web 2 data actually. We can't rely on Web 3 or let's say on-chain data only because of how our NFTs are and the smart contracts are structured. This is referring to the data architecture. We'll touch on it later. And this is something to actually be kept in mind from the very early start. How can reputation be built up? Okay, Aaron, verification versus validation and the macro loops. All right. Loops that you may accidentally create if not careful. Oh, that sounds interesting, Aaron. I'm not sure if you want to elaborate on that one.
Well, sure. I mean, the way it goes is if you now, I mean, at the end, the design loop is pretty similar to what we usually do as a trader. I'm by trade a hydrodynamics engineer. Mm-hmm. So if you're designing a ship or any moving craft, that you might require intense amounts of calculation. Mm-hmm. At the end. I mean, there's some distinctive, pivot points in which if you're not careful and if you're not asking the right questions, then you might end up just going back and just redesigning an entire thing, and just that effectively has just fell on our table, not just in the software engineering, and in any design and engineering process that might just put you in a really awkward situation. So. It's not, the entire thing is a key takeaway, the way it was actually put together, and I thank everybody for it. Just put in, because it just the way those videos have put this in was I think very straightforward. But in the end, the questions like verification, am I building the system right, and validation, am I building the right system? Is, I mean, that was a good. Sort of a good description of the whole thing, because at the end, you don't want to ask, am I building the right system too late?
Okay, too late. Yeah, absolutely. And that's why requirements are, again, a topic today. Thank you. Sangam added, how to sync requirements, architecture, design, and development. Yes, absolutely. Agree. ARC added, regarding the MATLAB video, being able to understand the different components of the system and how they work together, NFTs, website, voting algorithm, etc. Yeah, also very important to establish this systems engineering perspective.
And I think that's one of the biggest things I've learned since being involved with token engineering personally. I mean, I had a strong math background, but I'm starting to see that there are all these different systems, but they have these commonalities in terms of the design, verification, validation, that whether you're working with software or any other type of system, it's really a similar process, which is what Aaron was amplifying. And the key is we don't want to do all this work and then get to the end and realize there was something really important that we needed that now we have to either try to sprint to get in, or we're going to have to start over. Neither one of those is a good feeling. So that brings us to making sure that of our requirements gathering process that we have been able to capture what's important here. So we had to cut the requirements discussion a little bit short last time, and this time we want to continue it and amplify it a bit and make sure that for our specific project we have captured all of the important requirements. So Angela, I believe I hand you now.
Yeah, let's please just click and we move on via your slide. So the next slide shows, okay, here we have two different, just to keep in mind for repeat the discussion last week. For those who have been able to join the session with Vitor, who is responsible for the implementation, and all others who hopefully had the chance to watch the recording of the session, we have on one hand implementation constraints because of the NFTs that we, the 1,000 NFTs already minted and how they are structured. And also because Vitor will take care for the actual implementation. So we don't have to build the smart contracts, test the smart contracts. This will be Vitor's role here if we go to the next one. But still, we have to keep these constraints when it comes to implementation in mind. And we have to be aware of those. And one next slide is this constraint around the smart contract. Of the, let's say, legacy TE fundamentals NFTs and others that we've minted throughout the last 2 years, where we know that they are all built based on the same smart contract. So by just reading on-chain data, we could not differentiate between the various classes of NFTs. Remember, we had this diagram showing that there are different types of NFTs with TE fundamentals NFTs, speaker NFTs. Run or go with Jokerais as an application, just on a side note. And that's a good example of why it is important to check the implementation constraints. There's one, Jonks, would you like to add something here?
I'm still not completely clear as far as what the consideration or the concern around Jokerais as far as I think a better solution for having or allowing us a lot more flexibility in defining and utilizing requirements.
Yes, the reason is that Jokerais just can't integrate Web 2 data.
Well, no, you can actually upload a CSV where you've got just a column of addresses, and then column 2 would be the weight that you want to assign. And I just went through here while we were on this session, and you can just upload a very simple CSV file, like I said, column of addresses and the desired weighting. And then that way we can use like a Google Sheet to have full flexibility as far as who can vote and what weighting that we want to give to that wallet address.
Yeah, that's true, but only on the level of a wallet address and not on the level of the NFTs held by this wallet address.
No, like we can, like, let's say that a person has 4 NFTs and we want to give 100 points to each NFT. And then like another potential might be that they participated in the sessions of the fellowship recipient candidate, then we might want to do some weighting, and then we just have whatever we want the line item to be in that weighting column, and it's got complete flexibility. Yeah.
So I would suggest, so I'm totally open. If we can solve it, I'm happy to solve it. So I'm not against Jokerais generally. I just want to highlight, we have to take into account that any tool we use has to be able to integrate the data to specify the voting weights that are available. And these might be on the layer on-chain data, and this might be also on in our database and not available via smart contracts. And if whatever solution we find, perfect. All right, so let's
I'll take that to the
continue
Discord.
this. Okay, cool. Right, next one. We went over the requirements collected in the requirements sheet, and again, Sangam, thanks for preparing this and everyone for contributing requirements. And requirements needed. And then from there, it's important to take the next step in classifying the requirements, being able to differentiate. So what's now our task and what is something we cannot accomplish by a voting algorithm still needs to be accomplished, and how. And this is what we'll take a look at. Let's pull up this. Good. So what I did, I took 3 steps, and this can be something that you can apply to pretty much any project. It's just helpful with first have this wide open, try to take all perspectives, collect all stakeholder inputs, look from different technical, business strategy, what we'd like to achieve, legitimacy in case of a voting algorithm, timelines, and try to cover and collect any information, and then take the next steps in classifying, building categories, and ultimately setting priorities. And this is what I did here. So I took the spreadsheet we collaborated on to collect the requirements, and here I added some TE Academy notes. And I didn't delete anything, just added comments in green. So that, for example, sometimes I felt, okay, maybe let's clarify the potential solution, how it could look like based on this input. Voting should be Sybil-proof, as Natishi added 1 vote per account, and I clarified, okay, TE Academy NFTs is 1 account and 1 wallet address per student. The NFTs are not transferable, and wallet addresses are immutably tied to the TE Academy account. And this is how we, with the TE Academy certificates and NFTs, how we are addressing this 1 vote per account and ultimately try to achieve Sybil-resistant systems. More, ballots are not transferable. The NFTs, again, this is our solution with TE Academy NFTs to provide you more context. The accounts and NFTs held are non-transferable. So the wallet addresses are non-transferable, and the NFTs are also not transferable. Both are immutably tied to an ID in the TE Academy database. And this is what we can work with in terms of Sybil resistant. Then Natishi added another one, announce voting results. So she said with preliminary voting results should not be visible until the end of the voting period to avoid strategical voting and ensure users' real need in the voting. This is another great requirement to avoid strategical voting. Then we have some more. Renee added voting off-chain. So this is my comment. Her question was voting off-chain or on-chain. And in our case, with off-chain mechanisms and tools, we can be more flexible while we verify, for example, the proofs for assigning voting weight with on-chain credentials, the NFTs. And similarly, verifiable results referring to how can people verify what the results of signing will be. I think this has to be still defined how a solution can look like, but I think verifiable results is a valid requirement. User-friendly interface is a valid requirement, particularly to increase participation. Then we have elicitation methods. So who should be eligible to vote? Who should be eligible to win? And here, again, let's be clear, our goal is to select one fellowship winner, not several, and all TE Academy students are eligible to vote. More experience in token engineering should result in more voting power. That's the general how we frame it. And another interesting requirement, I must say, is who is going to decide which voting mechanism we pick. And here, I mean, there's a reason why we collaborate on designing this voting mechanism. So our goal is that the track 4 participants agree on the voting mechanism. I guess we'll have to find out how we agree, but generally this should not be something that we simply select. The process in verifying and optimizing this algorithm should lead us to a good decision, to a good joint decision. In case there is a dispute, TE Academy has a veto, but my goal is definitely to make this decision we take together, right? Another requirement here too that NETs contributed. Voters need to have info about the candidates and what they do during this season in order to vote. This was referring to ensure to update the community about achievements. I think this is a description I tried to clarify, and I hope I've nailed it. Not in case you would like to change it, feel free to do so. So we have to provide information and what they should do during the study season and after. And there should be evaluation in 2 dimensions, TE token engineering achievements in research and practice, and B, sharing knowledge in the live tracks. And actually this requirement brought up some more interesting questions on edge cases, and get to this later. So thanks for adding this requirements. What information is important to share to the voters? Then another one by Nuts was, how can we manage that the quality of fellowship candidates is actually high? So 50% of praises for teaching, the candidates could gain an achievement badge to create reputation and trust. This could be a solution. That's why I didn't put it in requirements. I would say, number one, being selected by a fellowship candidates and on the 4 candidates shortlist is already a proof of achievement when it comes to this dimension A, TE achievements in research and practice. And yes, I would say, and this is actually, I could be more precise here, I just realized candidates prove in some way that they delivered all 4 learning sessions, right? This is the minimum requirement. And for the rest of it, Nuts, I feel that it's rather about the evaluation and the voting of the voters than establishing an additional point systems on praise for teaching to represent the session quality. But let's keep this in the requirements list, and happy to discuss further. All right, then we have more by Skrilla. Avoid strategical voting. We already had this. Some more comments here that I think are really valuable. For example, private voting until the governance period ends. This could be one solution to solve this avoid strategical voting. And that's why I added here this is a solution and this is a requirement, respective requirement. 10th God added a dashboard to show each user's reputation score, voting power. Again, to me, this is in the first place a potential solution. Question is what we'd like to achieve. A user should be able to know how much reputation she has built over time in TE community. That's, I think, is a cool idea. To me, this would be about voter activation. So I see that I have an impact, and that motivates me to vote. Jonas added voting available for all TE account holders with a linked wallet. Yes, agree. Then there was another one. We have minimum requirements for voting. Create a list of minimum requirements such as attended some live tracks 5 to 8. Yes. We say only voters who have a minimum knowledge about token engineering represented by NFTs. Right? And there's a second submitted by Joanne that refers to a similar question. All voter groups should see that their vote matters. So we had this voter activation, and all votes must count. Yes. And I've added, respectively, all votes, but still there should be this limitation, only voters who have a minimum knowledge about token engineering. Makes sense? I hope so.
Can I?
Yeah, good. Yeah, absolutely.
Yeah, you mentioned last time that a voter would be eligible if they have an account with a wallet connected, even if they have no NFTs. So just to specify the eligibility criteria here, is that NFTs or is it just a connection?
Yeah, you are right. I thought back and forth, and we'll get to this also in the edge cases. I mean, generally, technically, we could say everybody can vote, but when it comes to Sybil resistance, having an NFT makes the whole system much more Sybil resistant. And for the overarching goal that experience and expertise in token engineering should matter, we could say that, and this is our decision, wait, it's not enough to have an account and a wallet address. You have to have minimum one NFT, because otherwise you just are not able to prove any token engineering knowledge. And so you are right. I would say, in this sense, we would say not all vote must count, but all votes with a minimum knowledge in token engineering. And we decide that there's a minimum of one NFT to be eligible to vote. And I think this makes perfect sense. With minimum one NFT acquired. Right? Good. I'm taking it, I try to be fast here, but whenever you have questions or doubts, just switch on your mic and let me know. We are lucky to have so many different requirements, and that's why I'm trying to go over all of them. Okay.
Why the category of what we just edited the last point? I think
This one?
yeah, no, the one up. all votes must all votes must count with one NFT acquired. I mean, how is that not proof in terms of category? Why
Yeah,
is it
sometimes.
voting further?
Sometimes you could discuss if this is more related to proofs or more related to process and infrastructure. I think I added it to process and infrastructure because Joanne said all voter groups should see that their vote matters. And that this is, to me, like information to prepare the voting, maybe the UI, maybe this also this application that shows, okay, how much does my particular wallet and with the NFTs held count. But of course, this refers also to the proofs. So sometimes we have just overlaps. Okay, good. Then Joanne added, TE knowledge and participation makes people more qualified voters, and I fully agree. So that the votes of such people should count more than random votes. Also, this incentivizes potential voters to work hard and get TE Academy NFTs. Perfect. I've added as a requirement, all important qualifications should be reflected in the weight assigned to a person's vote. And solution, potential solution would be to classify the NFTs and associated qualifications and then derive a voting weight. Then we have another one that is referring to avoid many active but not sufficiently qualified students to outweigh TE knowledge. So Joanne describes a scenario. A high percentage of grateful participants is a good signal. Yes. Active participants are more qualified than random voters. Participants are generally more likely to vote for the candidate they know, but using the percentage rather than the raw number would give a fair basis for comparison. So this is referring to a solution that is like candidates could earn participant satisfaction points based on the percentage of their own live track participants who vote for them. This is already, I would say, a pretty sophisticated solution, but why not? I would just say that participant satisfaction and activity only thus should not outweigh TE knowledge, right? Okay. Then, Joanne, another scenario. Candidates could earn peer respect points based on their percentage of high context voters who vote for them. Weight high. So to me, this is again votes of, for example, votes of fellowship committee members and other special contribution NFT holders should count extra. Yeah. And a final one from Joanne. Voters who have connected a wallet but do not hold any NFTs have very little basis for voting, but we would like them to still take part. This refers to this initial point we discussed. Maybe we change it or can finalize the requirements. Either we give them little voting weight, those who don't have any proof of TE knowledge, or they are not eligible. Which I would say the second seems to be more reasonable in this context, but again, happy to discuss. Then we have 3 requirements submitted by ARC. Make it transparent to participants in how the reputation scores. And this is, we had a similar requirement earlier. A second by ARC, voting system weights must reflect the various levels of experience. Yes, again. And also good usability. Agree. Jan submitted tiered voting eligibility for T potential solution for me, the general requirement is voter diversity, avoid that a small group of participants groupthink can define the agenda outcome. And we could solve this via tiered voting eligibility. Victor submitted 3 that refer to the voting period. And of course, these timelines are important. And we'll have a voting period of June 13th to June 20th. This is what we defined now. There are some buffers, but let's, for now, plan with this timeline. And we have to work against this timeline. Victor also submitted voting mechanism simplicity. We had this conversation. We can build a super sophisticated mechanism, and then it's hard to understand an individual voter's impact might turn out to harm the voter participation. At the same time, of course, sophistication, and we had some potential solutions on more sophisticated solutions, can achieve a better result, and we have to keep things balanced. Weighted voting, yes, we had this a couple of times. Then we had participation, high participation rate. How can we measure high participation? I just throw a number that feels to me, based on the students we have, the number of students, the number of active students, feels reasonable to me. Minimum 100 wallets to participate in the voting. This could be our goal. Then Felix, honest voting according to true preferences. You said, how can we incentivize honest voting or design honest voting with a mechanism that should guarantee that at least to some amount that the payoff for voters, payoff to be discussed, if they follow the strategy of honest voting, is greater or equal to the payoff for following any strategy of strategic bidding. I mean, incentivizing honest voting cannot result, in our case, to a monetary reward or so. But of course, we can build a mechanism to support voting according to true preferences or avoid strategical voting. Felix.
Yes. Hi, Angela. So I wanted to clarify a little bit what I meant with this. So the idea is drawn from other concepts from mechanism design. For example, in auctions, you sometimes want to discover some values, and you take the input from the participants to discover the value. And for me, in this voting, it seems a little bit like, and I also thought about this because, as far as I understood, we are trying to design a voting mechanism that can be applied generally, right? So also in other circumstances. Yep. And especially in this case, for me, it seems like the votes of the participants are assigning somehow a valuation to the contribution of the fellowship candidates. All right?
Yeah.
So with the votes, we can at least estimate how much value the fellowship candidates provided to token engineering itself and also for the students. And so that's basically what I meant with the payoff. So the payoff for the students is the value provided by the fellowship candidates. And yeah, so that's also what I wanted to mention in the last comment from the line, that it's somehow really, it would be really hard to define an equation that captures the provided value and everything else. So it seems kind of hard, but I think it's at least necessary to have something like this in the requirements, even if in the end it's not possible to measure or to achieve this. Yeah.
Okay, then we would say measure contribution to the field by candidates And this would even be establishing a metric. And the second element to it, to me, is still honest voting. I mean, you're touching on a super interesting area, because there are so many grant systems out there, and the big topic in any grant system is how can we measure the contribution to the field and reward this in an objective way, so that we find these metrics to quantify a contribution to the field. And if you say payoffs, this would be quantifying the contribution to the field. And super interesting topic. Let's see what we can make of it. Okay. I'd like to highlight a final one. The mechanism should weight those in favor for the higher levels of participation and knowledge in the SME of the candidate, taking tracks and completing them. So I would say this is definitely participation in SME. Can we reward active participation in the courses on the voter side? Yes, we can. You can acquire an NFT for your contributions and achievements in learning, and these NFTs give you more voting weight. So yes, this is definitely a requirement. I also put some out of scope, not because they wouldn't be good requirements. It's rather because of time constraints, change voting or multiple trials testing. Not sure. I mean, if we can implement it, I'm super pro. It's just with a voting period of 1 week, these trials might be limited. And what should be the purpose of trials? Maybe we should specify. Then define motives and objectives for voting. Voter motives and objectives should be defined before the voting exercise. Voters should be given a space to input a few reasons why they voted, or if they understand why the voting process is ongoing. I think this is generally super relevant, and in further developing the voting for fellowship prizes or other routes to further develop the field, this is super relevant and important. It's just not our scope over the next 3 weeks. Another one is general leaderboard of candidates from all seasons. At the moment, we only have 1 season. That's why it's out of scope. But looking for long term, this is certainly an element. Also tracking contributions and how were fellowship winners and candidates able to further develop their work, and how had this an impact in the token engineering field? Super interesting questions. And Ethereum attestation services, that's out of scope because, again, it's a new way of measuring, and it's adding a new element of proofs that we would have to establish first. And we should build on the proofs we already have, given the timelines. Good. I then sorted these requirements. So I added some by TE Academy, but let's go over them. I think there's nothing new here. So make use of TE Academy certificates. This is something I mentioned a couple of times. Voters select the single fellowship candidate, so not multiple winners, only 1 winner. Anyone with a TE Academy account plus wallet plus NFT can vote, right? Civil resistance is important. Make it hard to game this voting. Voting weight, special contributions have a special and highest voting weight. Airdrop attendance NFTs, for meaning you attended only without proving certain knowledge acquired, have a lower voting weight. Some timelines requirements. The minting season opens on June 6th. And we have to include some Web2 data, just because not everything we have to take into account or should take into account based on voting, or to get to these voting weights, is available on chain. So these are just the ones that I added to clarify. And now this is a whole lot of, sometimes overlapping requirements. I kept them because they are all relevant to gain a good understanding of what we'd like to achieve. But then the next step that you always should take when it comes to requirements, build categories. And here we have categories, the development process. So who is taking the decision what voting algorithm will itself, and we'll get to this in the course of the session. The proofs we can build this voting algorithms upon, the NFT certificates, the voting process and infrastructure, so the environment we embed our voting algorithm in, the voter activation with additional elements where people can maybe verify or check what voting weight they have in the voting. This is what I assign to voting process and infrastructure. And these are basically the categories. And when sorting it, you get a much clearer picture of, okay, what is now relevant, for example, for the design for the voting algorithm, and what proofs can we use and should we use? Plus, what additional measures should we take? And now finally, let's get to priorities. So I took the exact same list of requirements and built buckets. Most important and out of scope, these are the ones that I mentioned beforehand, and some, if feasible, where I'd say, okay, this would be really cool if we can achieve it. And then build buckets like the development process, the timelines, requirements referring to the single winner, make TE Academy, NFTs count, and the requirements around this one, voting according to true preferences, Sybil resistance and robustness, participation and transparency. And these are then the categories plus priorities. And I'd like to invite you to first check out the own requirements that you've submitted and see in the full list of requirements. And B, of course, now continue building this voting algorithm, check back and, okay, are we still on track? Are we still delivering on the requirements when it comes to the different components and categories? Good. I think that's it. Any questions before we take the next step? Yeah, Victor, you raise your hand.
Hi, Angela. Hey, everyone. Yeah, I have a question because for the weighting, so I think, so we have obviously decided to give, every NFT has a specific weight, but to understand exactly like how much weight we actually want to give an NFT, can make it easy and just say 1 + 1 + 1, depending on how much NFT you have. Or also, I was wondering from an attack perspective, if we could somehow try to make an estimate how many are actually enrolled, or how many students there are, or how many are connected to the wallet. I think now we changed the requirements a little bit, and we say just to have an expected, number. What is in the worst case scenario if there was an attack? Like, how fast could people just enroll, do the first NFT to kind of vote, and that therefore kind of give it a number, try to estimate how much is the delta between the minimal requirements and anybody else, because then we could fine tune a little bit the motivation, but kind of bouncing off from what Joan, I think, said, the motivation, not take away the motivation for minimal requirements voters, but then also kind of have this weighted system that we're long for. What do you think?
Yeah, absolutely. I smile because you are actually talking about the next steps we want to take here, because when it comes to token engineering, part of it is that we verify the design we develop against metrics to how can we find out if we really meet these requirements. And the numbers you mentioned can be around, there are more elements and steps we can take. And yeah, thank you for this contribution. Stay tuned. We'll get to this point in the next couple of minutes. Okay, here's just for everybody's overview. I've mapped out the timelines again. We should check the first implementation check, run it with Vitor next week, just to let him know this is how we plan it and are there major obstacles. Then voting system implementation and testing should happen between May 27th and June 6th, so soon. Then also to keep in mind, the free minting and study season minting will take place June 6th to June 22nd. Keep in mind that not only the NFTs minted so far should count, there'll be a certain number of people who still want to mint their TE Fundamentals NFTs, and they are waiting for the free minting to open on June 6th. At the moment, you would have to pay a fee. And also the study season NFTs can only be minted once the sessions, the learning sessions have taken place, and this is then earliest June 6th. The voting period, again, is going to be June 13th to June 20th. So by then, latest, we have to implement our voting UI. And on July 9th, we'd like to announce the winner. So this is the full set of timelines. Jonks.
Yeah, I'm just trying to understand why that we're doing the voting period where it would only allow 1 week for people to do the free mint. And then there's that big gap from June 20th to July 9th. It seems like if we're wanting to get a more inclusive audience, we should do the voting period after the free minting session concludes.
Yeah. Okay, some simple reasons. This is our buffer. We might need it. If we find out we don't need it, I'll be happy to extend the voting period, for example, or I'll be happy to extend the free minting. The reason is as follows. We have had cases, or we have seen cases in the past where it was not possible to implement the full voting algorithm with an application, and there had to be some manual steps to be taken to land at the ultimate voting result. And just in case we have to run additional manual steps, we have included this buffer. If we find out all super simple, easy to implement, happy to extend free minting as well as the voting period. Sounds good? Good. Good. That's it on the requirements. Andrew, please take over again.
We have a lot of really great requirements, and now we face the challenge, the engineering challenge of how do we translate those into things that can be verified and checked. I want to say it's possible, as we've seen, that some of the requirements may be incompatible. And so in that case, we may have choices between how do we translate those requirements to what we can do, and how do we make the choices on the trade-offs. The big takeaway from last week's discussion of Arrow's theorem is that no voting mechanism is going to do everything we want it to do. And so the most important thing we can get out of this is being really clear about what we want it to do. And we recognize these are the weaknesses, and we've accepted these weaknesses. We know what these weaknesses are, and we know going in that we know what we're dealing with. So how will we know? What are the requirements for the requirements? How will we know if the algorithm or the mechanism that we choose actually satisfies the requirements? And this is like a fundamental human problem. How do we know that anything is actually satisfied the requirements that we had in mind when we started the design? So there are some tools that we can use. We've already mentioned the idea of using functions. So quadratic voting, for instance, is based on a mathematical function that calculates what the value to each voter should be for a particular project, and also the value that they will, or the value that they will contribute, the donation that they will give. What quadratic voting is intended to do is eliminate this gap. There should be no incentive under quadratic voting for any voter to give less than the actual value that they get. Quadratic voting is not inherently a pro-democracy mechanism, it's an anti-free rider mechanism. Mathematically, quadratic voting does that perfectly. However, in the real world, there are issues with Sybil resistance because the mathematical proof that quadratic voting achieves no free rider depends on knowing that each voter has a unique identity, which we cannot do in the real world very easily. We can look at simulations, and today we're going to start looking at what simulation tools would look like. And here we could define, okay, and here are the criteria I'm looking at. So for instance, simple plurality voting, where you just add up everyone's number one choice and take whoever got the most of those. It satisfies the KPI that the smallest number of people will not have their number one choice satisfied, or the largest number of people will have their number one choice satisfied. But what it doesn't guarantee is that we'll avoid everyone's least favorite choice. And so that's a trade-off that we have to make, and we can discover that by looking at what are the different scenarios and how do these things work. And finally, one that I'm going to advocate for pretty hard is test cases, where you look at, here is a specific situation that could occur. And if the situation were to occur, what do we think the right outcome would be? And that way, if that situation occurs, we know in some sense that we've already made that decision and we don't have to think about revisiting it. All of these are great methods of thinking, how will we get something that does as much of what we want it to do as we can? And I'd like to use an example from my domain, which is math. So if we ask for a line and we're willing to shift the slope and the y-intercept, and we say, I want it to pass through the point 0.02, well, there are lots of lines that can do that. If we say, I also want it to pass through 1.3, then there's only one line that can do that. I'm sure I'll find it. There we go. But if I say I want it to pass through the points 1, 2, or 0, 2, 1, 3, and 4, 5, there's no line that can do that. And so we have to be careful that we don't constrain ourselves out of the possible space of things that we can do. And that's an important consideration as we're making these. There are lists of voting criteria that are already known. For instance, one of them is the independence of clones criteria, which says that if we vote for everyone's favorite instructor, and y'all vote for Angela over me, if we were to rerun the election with 2 copies of me, I shouldn't suddenly have one of the copies of me win. This seems like a really intuitive, criterion, but many popular voting systems don't satisfy this. If you add a copy of one of the losing candidates, it can actually change who wins the election, which is extremely counterintuitive. So in terms of translating these things, what I want to strive for today is an understanding of the parameters that will be available to us, and that could be a very wide design space, but also how will we know what the best parameter choices are, or what acceptable parameter choices are. Because we think about risks versus satisfiability, we might be in a situation where it's better to avoid disaster than to come up with the best voting mechanism. That's something we might consider. One of the requirements we didn't have would be if someone gets 0 votes, they shouldn't win. But that'd actually be a really good requirement to make sure that we have nailed down this. Of course, in this discussion, I want to focus on the voting algorithm. And what I mean by voting algorithm is how the votes are actually counted. Now that lives inside a larger space. like which is the voting system. For instance, in some voting systems, it's a little bit harder to distinguish these. Like in a pairwise voting system, the order in which the candidates are presented can matter, and that's actually part of the algorithm. So if we want to explore that aspect of the design space, then we can. But I'm going to focus mainly on assuming that we know things like, for instance, how are the credentials issued? How do we then translate that information into a final result? And the voting system lives inside of a larger decision-making space, because ultimately Token Engineering Academy will use the voting system in its decision process. But if there is some unprecedented situation, or for instance, part of our decision-making scope that is larger than the voting system is how do we choose the voting system? Are the candidates presented in the same order, or are they randomized? That's a decision that's made outside the voting system. They could have an impact on the final outcome. I see a lot of comments, which is great. I don't know if any of them are things we should stop on. Angela, I'm gonna keep rambling for a moment, and then if anything in the chat needs to be shared, I'll just trust that you.
It's all good. We just found more requirements, and we are adding it in the background. Just go on.
Okay,
so
cool.
No need to stop here.
When we think about parameters of a system, I'm using a working definition. I view a parameter as something that is set before the system begins operation, and then influences it, and typically is not changed during a run of the system. So my go-to example as a mathematician is the parameters of a line are its slope and its y-intercept. If y-intercept, and you use that line throughout your entire modeling process. Now, when you do it again, you could select a different slope and y-intercept, but you're not going to be changing them constantly in a typical application. I'm American and we like to drive. Maybe you also like to drive. If you think about the angle of the steering wheel, not how you're turning it, but how you're positioning it towards or away from you. Typically, you're going to set that once when you get in the car, and then that will impact how you drive for the rest of the trip. But you're not going to be constantly adjusting it. You'll set one fixed position for the steering wheel in terms of how far it is from you. And that's what we need to do. First, we need to find the design, the overall design, and we'll talk about some possible design choices. And then within that design, we need parameters, which are adjustments of individual things. And the examples will hopefully clarify this a bit. So I have here a general voting mechanism framework. And I will say not everything fits this framework, but a lot of it does. And we could frame the current problem as something that does. Mechanism, where we take two chunks of information, essentially. One is of the voter information itself, which will be the information about each voter. Now, in our case, it would be something like how many NFTs each person has, or which NFTs each person has. It might also include when they joined the Discord, or when they got NFTs. Whatever information we can access and want to use would go in here. And then there's the vote record, which are the preferences that they actually express. Now, there's a lot of variability here in addition, even if we're just looking at vote record, there are choices. But we're going to take these two pieces of information stored in some data structure and run it through a processing calculation, which produces the final result. Now, what we don't have here is anything that would be iterative, by which I mean rounds. It's assumed here that we're taking pieces of input one time, putting it into the processing and sending it forward. We don't have like a runoff mechanism. We don't have, this would not, for instance, encompass pairwise voting. This wouldn't encompass conviction voting, but it's a good starting point for us to talk about how the design space works and what the parameters are. So in terms of the vote record itself, we have a design choice. What are the different possibilities we could ask for in terms of what the voters actually input to signal for processing? And y'all can drop them in the chat or quickly unmute and say them out loud, because there are several different possibilities here.
Aaron asks if you could repeat the question.
Sure. So we're focusing here on the part where the voters are expressing who they believe should win. Even that's a little bit, the voters are expressing something. They're giving something to the processing calculation that is then used to determine. So one possibility is they could give a single candidate. They could just put one name. What are the other possibilities? There are a few others.
Ark just mentioned in the chat, they could rank the candidates or a plus and minus, like dislike or like.
Okay.
Joanne added they could just appoint one preferred winner. That's the first solution. There are more. A list of preferences. Aaron? Jonas added a list of preferred choices with weight or percentage. All right. So voters assign choices and weights or percentages. Violeta added percentages from 100.
Cool. So even with this one thing, there are different possibilities. And this will make it, for instance, if we have a ranked list, do you have to rank all of the candidates? Can you just rank how many you feel like? Because if you only care about 2 and you rank the last 2 arbitrarily, that's noise, right, that we would be taking. And that might work against some of our requirements. There's one more option, which would be approval voting. You could just say, I'm not expressing preference, but I would be okay if any of these people won, and we could work from there. All of these are different things, and these will create different situations or complexities when we want to do simulation. A ranked list of 4 candidates will have 24 different possible orderings, whereas a single candidate will have 4 different possibilities, 5 if we say blank, but and exploring those 24 different possibilities assigned hundreds of different ways is much more complex and may potentially make it harder. But on the other hand, we would have a much richer design space. So that's a trade-off we're making now in terms of our decision-making process. I have an example here of how you can take quadratic voting and fit it in this framework. Just that the voter information nowadays takes passport as a form of anti-Sybil defense in the vote record. I'm going to move forward to one possible, and I'm saying one possible design, the choice that we could use. It's something that's used in some different mechanisms that are similar and being used now in Web3, and it's called weights and gates. So the weight would be the amplification of whatever your credentials are. An example of this would be the early pre-Gitcoin passport trust score that was assigned, where your trust score would be used to assess, could be used to assess how much your vote counted. In this case, And I am not saying that this is the design. I'm not saying I think this should be the design. This is just an example, okay? Y'all are not my undergraduate college students who say because I throw an idea out there, it's how it should be. But if we were to say any TE course NFT has a value of 1, and all other TE NFTs have a value of 2, and we're going to take all the NFTs you have, add them up and add 1, and we'll multiply that by your vote. That would be an example of a weight. We assign weight to the individual credentials, and then we weight the overall vote by the sum of the credentials. Now, if we don't think that non-NFT holders should have their vote count, I would delete the +1. I have the +1 here so that even if you have no NFTs, your vote still counts as 1 vote. And if you have tons of NFTs, your vote might count as 20 votes. The second thing, which is also a multiplier, is a gate. And here is something where we might want to adjust, for instance, for how long people have held these NFTs. We may say we're only accepting NFTs created with this date. And then if we took these things, and one approach would be to multiply the weight times the gate times the single vote and add them all up, and then whoever has the most wins. Now, even within this one design, we have a massive design space because we still have to determine how we will weight and process these individual weights and what potential gate functions we might apply. One, again, I'm not saying this is a design I prefer, it's just an example, is we could take the number of days held divided by 365 so that if you had not held your NFT for a full year, there would be some form of discount on it. And we could adjust that as well. So I'm trying to express in a quick way what I think of as a design space and parameters within a design space, because my understanding is probably by next week, we need to have a sense at least of what feasible possible designs are. And then we'll have a few weeks to explore the parameters within that design space. Angela, does that track with what you were saying in the timeline? I realize I just ambushed you from chat watching, sorry.
Yeah. What should I confirm? Sorry.
So next week, what we want to have is a set essentially of our great ideas about voting lines. Which ones are actually possible to implement in Snapshot? Right. And then go ahead.
Implement in Snapshot is not the only question, but definitely we should have an idea how we'd like to structure it. So, for example, we should have 1 or 2 solutions we can discuss how to implement weights and gates, or if gates are involved. Design decisions should be taken next week. And then from there, we continue with optimization.
Well, one of the constraints will be the feasibility of actually implementing it in some form that we know, because we don't want to take a big jump and risk that something is actually too complex to implement, right? So I was going to put some discussion here. I think that maybe this should go in Discord because I think in terms of time, we need to move on towards the computational side. But another possible design that I'll just throw out here is you can do clustering or grouping. And for instance, we could say, we're going to group together everyone who has no NFTs and put that as a single election. And we'll take the winner of that election and we'll weight that in some way. And then we'll do it with a different group and a different group and a different group. And this is actually really common, right? The Electoral College in the United States is based on this, where you're grouped by the state you live in. In the US, we essentially have 50 sub-elections that are then aggregated to determine a final winner in some way. But also the current clustered quadratic voting model is this. So you're grouped with other people who are voting similar to you, whether they're Sybils or whether they're just similarly interested. And then your votes are actually discounted based on the similarities between you and other voters. So we could group and say, roughly speaking, these are low information voters, these are medium information voters, high information voters, and combine in some way. And I'm not saying we should do that. But one thing this would do is this would provide, say, a strong civil defense where we still could have people with no NFTs have their votes count. But maybe no matter, even if you had 1 billion Sybil accounts, it could still only influence, say, 9% of the vote. Does that make sense? So there are lots of other voting designs. I'm not saying either of these is the right one, but I'm saying whatever voting designs we're looking at need to be clearly spelled out in terms of how information is being processed and what the parameters are. And I'm primarily a mathematician. A lot of my mathematics overlaps with computer science. I would never call myself a software engineer, but one thing that I would say is an inspiration for me is to look at the modeling languages and the design languages that are available for software programs. And you can see in a well-designed software program how the information actually flows and what each component does. And so for the designs of our voting algorithms, that's what we're hoping for. Now, in terms of testing and validation, one thing that I would strongly encourage and perhaps insist that we do is design some specific cases where we know what the outcome should be. And some of these will be quite easy. But this moves us towards solving this problem of we want a mechanism that's an algorithm that's fair. Okay, if I'm a whale, I think that 1 token, 1 vote is fair. I think I have the most stake in whether or not this vote is successful because I hold the most tokens. So I should have the most say. People who hold fewer tokens would disagree. We need to have something that moves us towards more concrete objective. And the functions that were discussed, if we could attach a value and say, we want to maximize this value, that would do it. And then the question is, how do we translate from our subjective sense of what we want to something we can actually measure? And here we're dealing with things that will be familiar in terms of testing for engineers with unit tests, where you're testing one specific thing, where you know what you expect the outcome to be, and you're verifying that on that input you get the expected outcome. But the challenge here is edge cases. So edge cases are ones that are weird to think through or that you might not think of to test. And I asked Angela, in her role as the client, to come up with some edge cases where she would find the outcomes completely unacceptable. And so one thing we can do is we can make sure that whatever designs we're looking at don't hit any of these. So could we briefly discuss these, Angelas? I think they're mostly self-evident, but any you want to highlight would be great.
Yeah, let's start with the most obvious one. All voters vote for candidate 1 and candidate 2 wins. This is a easy to test case, but still it should be on our list. Then wallets with 0 NFTs outvote all others. This is what we just discussed earlier, and maybe we can even remove it or one solution is that just you are not eligible to vote at all with 0 NFTs. There are more, let's say, interesting ones, because then testing, finding ways to test will be more exciting, I'd say. Wallets with TE fundamentals, TEF is TE fundamentals, module 1 and 2 NFTs only outvote all others. second similar one is wallets with study season fellowship NFTs for the respective candidate outvote all others. So this is against, imagine this is also about voter activation. So the people who are taking part in this study season at the fellowship sessions, of course, are closest to the fellowship candidates, right? They are can be activated for voting much better than any other members of the TE Academy community. And that's why we should be careful with, can they outvote all others? And this is something we should verify. And also wallets with student NFTs only can outvote those with special contributions. And this is just to provide you more context in the bubbles on the right. Generally, the token engineers with special contribution NFTs, like speakers at events or course authors, have insights on what token engineering needs and what is missing today on a day-to-day project research work experience. And that's something that I want to be reflected in the voting algorithm. Similarly, the fellowship prize should signal what matters today to further develop the field. I mean, this is our mission. It's not only about selecting a fellowship winner once. The winner will be the example of what matters most, and why, and that the achievements of this fellowship winner and the contributions to this field are relevant today. And our assumption is that special contribution holders of special contributions, and we can elaborate more on the exact what NFT represents a special contribution. We could easily create a list. These people have a day-to-day experience on what matters in the discipline. And that's why their voice is super important. And the first two ones, I think, are referred to the outweighed participants in the study season versus or fellowship candidate skills in creating great learning sessions versus their achievements in the sector. And we say achievements of fellowship candidates should weight more than the learning experience, because not every fellowship candidate might be a good teacher by nature.
So this gives us some tough things, right? So let's say there is candidate A and candidate B, and all five special contributions NFTs vote for candidate A, and all 600 of the student NFTs vote for candidate B. We have to decide. I'm not putting you on the spot to decide this right now.
Yeah.
But our mechanism will have to decide in that moment. And no matter what we do, we are guaranteed someone will vote for someone who does not win. And some people will be unhappy with the result. And that's our we live with that. But it's not a fun thing to think about.
Yeah, these are some nuts to crack. I think it's super important to be aware of these edge cases and formulate these edge cases, no matter if you're designing a voting algorithm or the other token mechanisms, because it's the only way to formulate what, if you are able to deliver on the requirements, like how can we define if we have met the requirements?
So one way we can do it is with good computational tools. And I want to invite, as one of the NFT points tasks, that if you would like to create a spreadsheet model, I have here for a weighted voting model, but I'm willing for this to be any voting model that you think might be a reasonable choice, where we can modify voter information in one tab, modify the vote record in another, and then see what the final results would be. Because this will allow us to easily experiment. That's the big thing we need. is to look at different. That's one approach. I'm not going to say that's the big thing we need. It's one approach we could take, is to run lots of experiments and see, does this behave in a way that I feel comfortable with in all these different situations? And if someone creates the spreadsheet, someone else should validate it. And I view these as equal weight tasks. So if you want to start a weights and gates model, or a multi-stage model, or there's tons of things out there. If you want to start a way that we can start playing with the design you think is cool, then you can earn a third. You'll be a third of the way to the final NFT Part 1 criteria. So we don't have a lot of time left, but I did want to ask. We had a really awesome other tool that we could use, a reputation-based voting playground that people could start using as well, and we could also start extending. So I was wondering if the author would be willing to engage for a moment and walk us through what this is. And I'm sorry for the short time, but we do want to definitely highlight this today.
I'd be happy to.
All right, great. So just as it comes up, if you would introduce it and tell us briefly what we can use it for, and anything else you want to.
Yeah, sure. So, yeah, it's just a very basic test framework in Python. And I did make a few assumptions which might not end up holding, but let's have a look.
Where
So
would you like me to go?
there are three Python files. If you could maybe choose the definitions.
Mm-hmm.
Yeah, there's a README file, so it's all there. The different types of entities that we would work with. So we have the candidates and the voters, and also we know that voters may have NFTs, and theoretically the candidates might have some accomplishments objectively that we could ask the voting algorithm to take into consideration, but I've only sketched that. So we have all the NFTs that were mentioned in Angela's slide last week. Yeah, just a list of the potential NFTs. If you scroll up a bit, we have what a voter is. So a voter is someone who has voted. He has pointed. That was my assumption, that he would just pick a candidate and say, "This is my preferred candidate." And then also the voter has a list of NFTs. And maybe some more properties that were discussed last time. He has a TA account, he has a wallet connected, and he may or may not be a candidate. And we may want to disqualify him based on that. Yeah. Then there are the candidates just above. Just wait, no.
Sorry,
Actually, I think you are not in my GitHub repository. I think you are in yours. It's not updated. But I'll just get that one. No, that's fine. So the fellowship candidate is someone who has an ID. I've just played with candidate 1 to 4, and he might have some accomplishments. Okay, then there's the test data.py. So these were just the types of entities. And then in test data.py, I've made a sample of candidates and a sample of voters that we could play with. Obviously, we could make multiple samples of voters. Yeah, and you can see, if you look at the list of voters, the first one voted for candidate 1, and this person does not have any NFTs. The second one voted for candidate 1 as well, but has a lot of NFTs, and so on. Then in vote.py, this is where the actually voting algorithms would be implemented, where we tested. So I made this very basic algorithm that just counts the number of votes for each candidate and outputs the candidate that got the most votes. So very basic popularity contest, no reputation involved. And the last couple of lines of the file just does the whole thing. Actually, it gets the sample from the test data, the sample of voters, and then it runs the popularity contest given those votes and outputs the winner and prints it to screen.
Cool.
So the idea would be playing around with it, you could make alternative voting algorithms and run those on any sample you might set up, and yeah, see what happens.
So we already have a tool that we can start using to explore one mechanism. And since it's in Python, it's easy to extend. I mean, it's not hard with the great class definitions. It would not be hard for someone to come in and change, like extend voter, inherit from it, so that.
Yeah, absolutely. You could easily change that so that the vote is a set of percentages instead of one person, or you could do all sorts of things.
Thank you so much. I'm really looking forward to exploring this and extending it throughout the course of the week. I think I'll discuss with you, how to proceed from here, but it gives us a place to start and already gives us an awesome tool for information. I really, really appreciate you making. Okay, we have to wrap up now to meet our end time, but I think we'll make sure that we are cleaning up and making sure that we're getting this information to Discord and GitHub today and tomorrow. And we do have some tasks that people can do, including setting up a spreadsheet for analysis of voting, writing a summary for the session today, discussing examples of design parameters in everyday life. I'm always unhappy when I use cars because people tell me they don't drive. So if you have something different than steering wheel, it'd be great if we'll put that in the Discord. And then find a partner and come up with a concrete edge case or failure mode for a voting mechanism we've discussed. So it could be, we discussed dictatorship, which has easy failure modes. We've discussed simple plurality. We've discussed quadratic voting. We've discussed weights and gates. We've discussed multi-stage or clustering. And come up with a way where this doesn't do what you would hope it would do, because every voting algorithm has situations where the behavior is highly undesirable. That's what Arrow's theorem essentially says. And I think we should, Angela, my thought would be that we wrap up now and let this overflow into the async, and we provide updates now to Friday for next week. What do you think?
I'm muted, sorry. Sounds good to me.
Okay. So I guess the professor in me wants to say class dismissed, but do y'all have any last questions as we're leaving this session and then going into the Discord and GitHub for further discussion?
While you think about your questions, I pick the ones that have been raised in the chat already. What is the deadline for creating the model in Excel?
So next week, what we're planning to do is an experiment session where we go through. So if it could be created by a week from today at the latest, so that other people can explore with it, that would be the ideal deadline.
And next is, oh yeah, Jonas, great idea. He suggests that Joanne, this could be also transferred to a notebook and to make it even easier and more accessible for people without Python prior knowledge. Yes, all right, yeah. Jonas, just take Joanne's model to a notebook. ARC, is it 2 students working per task?
So for the spreadsheet, it is actually set up and validate. And I was envisioning this as people working together to get a sense of whether they would want to collaborate for the rest of the course. But it doesn't do any good if we step together and validate it together, because we'll miss something. We want some of that like adversarial, carefully checking approach that we've seen excellent examples from the students where they really are checking, the logic of what's happening. So if you create one, maybe find someone to validate it or get a volunteer to validate it. And if you want to validate one, just put your hand up.
Okay, nice. First teams are forming. Let's define the volunteers for setting up and validating the spreadsheet. Who is open to take this, set up and validate spreadsheet for initial analysis of voting mechanisms? I mean, this is the initial spreadsheet, and then it's everybody's team's own task to customize to further exploration, right?
Mm-hmm. Yeah.
Anyone? We have still a lot of people in the call. I start with the second one, maybe simpler. Write a summary of the session, documentation. We had a first volunteer. I'm just looking for the name. So sorry. It was, I'll find it, Sangam on Discord, who provided, oh no, it was not Sangam. Sangam provided the requirements list. And then it was Aaron, right, to write the summary. Aaron, yes, thanks. So you can reach out to Aaron. He provided an excellent first summary. You can build and reuse this document and just add the notes of this session, adding the links as well, references to the models we've discussed, to the resources we've discussed. Who is going to take over here? Write a summary of the session, collect all links, 8 points. We have so many good writers in the session. Yeah, Jonas, take it. 8 points for you. You'll make it work. Thanks. And now we need a second volunteer for the initial spreadsheet. It's super helpful for everyone, just build on something so that we have a shared structure, easier to compare.
We won't let
Maybe
you,
it's
we won't let you fail. We'll offer support and help.
Absolutely. And it will be a great learning experience, I must say.
Yeah, okay, so I could do this, but could you please tell me again the details of this task. So what's intended to achieve with this?
Yes. So it should be possible that if you, very similar to the Python model, there should be one tab where you can change the voter information, things like which NFTs they have and other information is needed. Another where you change who they voted for, and then finally a place where you see the final results. So that if you want to say, oh, what would happen if this one person didn't have this NFT, it would change the outcome. And it can be for any of the mechanisms that, any reasonable mechanism. Does that make sense?
Okay, perfect. Thank you.
It's funny because we're doing requirements gathering. We're constantly having to specify the requirements of what we're asking for.
Yeah.
Oh, so Jonah, I think it would be awesome. So I had my own software that I was working on because I had warning that this was coming, so I've been working on it for a few weeks. I think what would happen if we had multiple tools is that would actually allow us to cross-validate each other. So that if one of the Python packages is predicting something and a spreadsheet predicts something different, that might let us know there's an error in one of them. So I'm in favor of developing multiple independent tools, especially for the stage we're at, where I think it makes sense to get more people involved and to use them in validation. So Python, I don't want anyone to that. There doesn't have to be one standard tool. I think that we should develop multiple tools because different people can be comfortable with different things. Fantastic. So one thing I failed to do last week that I will take responsibility for is to post some discussion threads in Discord about specific things. And please watch for those. And is there anything else before we go out into the world to think more about voting?
And maybe a first indication of high versus mid versus low voting weight. I think this could just give you a better perspective and will be relevant for the ultimate definition of weights, I guess. So we'll have it in the course of next week. For now, just work with assumptions on weights. Any other final comments, questions? I hope you are all excited for the next steps to be taken in teams now. And we are excited for the solutions and the ideas we'll discuss next week. Cool. Looks good. Again, always feel free to reach out on Discord as well. And now happy collaborating and happy working on the voting mechanisms. See you next week.
Thank you. See ya.
Thank you. Bye.
Bye. Ciao.